Allis Chalmers announced and demonstrated the results of its initial research on fuel cells in August 1958. The original unit produced enough electricity to light two 15-watt bulbs. A fuel cell is a means of obtaining electrical energy from a chemical reaction. The initial Allis Chalmers design called for the use of hydrogen and oxygen gases reacting in an electrolyte. If the reaction is controlled, it produces an electric current, in this case enough to power a fan motor. By March 1959, Allis Chalmers researchers were convinced by the data they had collected that they could make a practical application of the fuel cell. Within a month, the cell unit design was frozen. The type of cell selected is fueled by a mixture of gases, largely propane. Now this new source of electrical power, fuel cells, has come out of the laboratory to power a vehicle for the first time. This tractor is powered by more than 1,000 fuel cells. They are combined in units of 9 cells each, and the fuel gases are fed into the units through a system of tubing. Chemical reactions occur within the cells, causing a direct current to flow through an external circuit which is connected by a bus bar to a compact controller. The controller enables the operator to regulate the speed or reverse the tractor's direction. Instrumentation necessary on this experimental vehicle would not be required in commercial application. Turning the valve starts the gas flowing into the cells. The chemical reaction begins and direct current is produced. The operator reverses the direction of the tractor simply by moving a lever on the controller. This reverses the polarity of the electricity flowing to the standard Allis Chalmers 20 horsepower motor. The speed and pulling power of the tractor is controlled by a second lever on the controller. By means of this lever, the operator can place the banks of fuel cells into various combinations of series or parallel connections. Protective covers are placed on the tractor as it is prepared for a demonstration in the field. The tractor has developed 3,000 pounds of drawbar pull on a dynamometer test. This field test through hard, dry ground, pulling a multiple bottom plow, demonstrates the pulling power of this engineless tractor. Although the basic theory of fuel cells has been known for 120 years, refinements of the original concept by Allis Chalmers Research Laboratories has made this method of producing electricity practical. Even starting the tractor with the plowshares in the ground is a smooth and easy operation because of a high torque developed by the direct current motor. When the free energy of the reaction is converted directly into electrical energy, as is the case in the fuel cell, there is no theoretical limitation on efficiency. The possibility of producing electric power directly from a fuel at an efficiency of 90% is truly startling when compared to the best diesel engines, which are about 40% efficient. The Allis Chalmers fuel cell operates at normal pressure and temperature. Because the fuel cell does not involve heat, but converts chemical energy directly into electric energy, it escapes the high heat engine energy losses. The application of the fuel cell is virtually unlimited. For example, fuel cells of the future might provide power for factories and homes, run vehicles such as trucks, buses, and earth-moving equipment, or even be used in military weapons and space vehicles. Even now, Allis Chalmers scientists and engineers are working on the next phase in the development of this new source of power.